Okay, so this is a summary of Dynamics Chapter 2, which is Kinematics of Rigid Body. So to do this kind of question, right, you have three ways to solve this sort of question. So here are the three ways. You got your instant center, body attached frame, and then your relative motion. So for instant center, the problem, some of which will look something like this. So got a rod that's lying against the wall and floor, and then it will slide this way. So that's one example. Another example is this way, where where there's like slots, this perpendicular slot, and then there's a rod attached these two connectors. And then as this A slide down, this B slide to the right, we will form instant center, just like this lah. Then for circular motion like wheel, right, it's known that the instant center is actually at the point over here because it's not moving at all at that point. So the velocity at the highest is at the further edge lah. It takes on many form and shapes, so it also looks something like this. However, one you need to take note is, right, for the criteria to use this instant center, right, is you need to have unparalleled velocity vector. So what I mean is, you see over here it's not parallel, so one go down, one go to the left. So it's not parallel, it will form instant center. So is this, and then even if it's angled oddly, right, also can one. The more important thing is you need to understand that it's applied with just one body. So in this case of example, you see there's two body. So the first instant center is actually related to this rod, because this rod attached at A and attached at B, and then it's sliding down this way, which is very similar to this example, just that now there's a wheel. So the instant center, right, is actually measuring the angular velocity of the rod and not the wheel. For the wheel, right, the instant center is actually the contact point. So that's one thing you take note. So for criteria for instant center, right, is unparalleled velocity and applied to just one body. So over here, one instant center for one body. Okay, quite simple. Next thing is body attached frame. So for body attached frame, right, you will always have the velocity. For example, this velocity of A is actually velocity of the A from respect to the attached frame, and the velocity of A prime, okay, which is the absolute velocity of A prime. So what do I mean? So you see this diagram over here, right? As this thing goes down and rotate counterclockwise, right, it will look something like this, you see? So it has rotated and then it has shrink a bit. So when I say when with A respect to the frame, right, I will attach the body attached frame as such. So as this rod, right, rotates, right, the frame will rotate with it, as seen over here. So essentially, what are you measuring? You're actually measuring the linear velocity over here. In this kind of question, different question got different meaning, but for this question, it's actually this linear velocity. You see this delta t? So within the time frame of here to here, the change in distance over the time is the linear velocity, because the rod rotates along with the frame. Okay? What about A prime? A prime is the absolute velocity of the imaginary point. So what do I mean by imaginary point? If you look over here, right, at the tip is A. So you glue a point over here such that it will not shrink with here, and then as it rotates, so it only measures the angular displacement only. So this angular displacement over time is your angular velocity. So that's what I mean by body attached frame. So just take note that A with respect to frame is essentially just the A with respect to this frame. The frame will rotate with it. However, for A prime, right, is actually the absolute frame. So what is absolute frame? Absolute frame is actually the frame about any fixed point. So this is a fixed point, so the frame is actually here. Okay? The third method, right, is through relative motion. So relative motion, for example, over here, you got this like weird looking thing. And this part is called A. As A goes down, this B at the same time will move out. As in this question, I would state that the B will move out linearly. So what's the velocity of B? Velocity B is actually velocity of A plus the velocity of B from A, because this is with respect to A so that's the velocity. Okay, it will take on many shape and form, so it will look something like this also. Okay, so this one you know the pulley question. Basically you measure the length has to be constant, and then you differentiate to find acceleration and velocity. So quite simple. So what the exam question that you might expect that you can expect to find, right, is something like this. You see? So this is a combination of, you see there's a lorry, and then this part is similar to the body attached frame. So I just taking this, I slap it onto a lorry. So this lorry moving, and then this thing rotate and contract also. So what does it mean? So when you solve this question, right, it's similar to solving this, just that now you need to add the relative motion of the lorry. Okay? So honestly, right, chapter 2 quite simple one. You just need to how to say, know when to use instant center and when to use body attached frame. For example, why can't we use body attached? Why can't we use instant center for this one, where the velocity is unparalleled? What? So why? The reason why is because it has to be applied to one body. Over here, right, you see this collar over here is one body, and then this A is another body. So you cannot use instant center. Instant center does not apply here. You must use the relative motion. Okay? That is why I did not use instant center in this example and this example as well. So that's all for the summary of chapter 2.